You know, it's Friday.
In terms of calculus. Listen up, guys. Quiet down, please. Be ready to take some notes today. Conversations end. In terms of calculus, how are x, v, and a related?
Position, velocity, and acceleration.
Yes.
They're all derivatives or integrate.
That's true. So if I have velocity and I want to get acceleration, do I take the derivative or do I take the integral? If I have velocity, I want to get acceleration, you take the derivative, yep. And if you want to get position, you take the integral, that's right. And it's the other way around too. If you want to, let's say you want to take the, you have information about position and you want to get acceleration, then what do? Double derivative, yeah, exactly. And this is all on your formula sheet too, if you have one.
Where is it?
Velocity is
Derivative that way.
Yes.
I have no clue.
Yeah, derivatives go to the right, integrals go to the left. So the derivative of position is velocity, derivative of velocity is acceleration, and then integrals go the other way.
So the integral of a is velocity. Velocity is the distance.
Yep.
Hold on. So let me write it down.
You should. In particular, I literally know when you turn pages. Like, you grade my test.
Yes.
I'm sorry.
You did just fine.
What did you write?
You want me to tell them what you got?
I don't even know what I got. So.
If it makes you feel better, I got a D.
Is it in Skyward?
I got a D.
You need to say it or do you want to check it?
Is it over 100?
Oh, it should be in there.
Is it over
I put it in
100?
just a little bit after you gave it to me.
Let me look and then how sad I am.
Okay.
You'll show me and we can just check them.
I got a
It
20
still
out of
says
30.
I have a D minus. And wait, you put it in Schoology or Skyward?
Schoology.
It's not in Skyward?
Should be.
It ranks differently. And
I synced it every time, so it should.
You above a D?
man,
You above a D?
The middle
Man.
grade.
I would be impressed if she was D or
pencil.
28 out of 30.
Alright,
Shut up!
Whoa!
Man, that's our
I got a 20 out of 30, but I brought some tissue boxes this morning.
One-dimensional motion. Write it down.
Yes, we are doing stuff.
You may have gotten a better score, but did you bring in tissue boxes?
I totally forgot.
Haha.
But I got 3 on the
Yeah, well, I got 2 on this buster, and I got 3 from tissue boxes.
I haven't gotten a single point of grade yet this year.
You probably still have a better grade than me.
I'm just a struggle bus all the time.
What do you have, Miss Black then?
The only thing I study for is drama. But even that, I don't.
I think I have an A too. My grade went from 104 to 89 after the test.
That's on you.
That is on me. I have a 98.75.
Oh, I read about this in the book.
I don't remember anything.
You did?
about
'Cause I sure- I
It says ID motion.
What was that, Katie?
Did you see my notes? Like I'm scribbling and my notes are interesting. Not gonna lie.
Main thing I remember about your notes is they were different colors. And
Yeah.
that made me happy.
Rainbow Order 2, and I skipped green because it's too light to read. Hey there, future. Where's Kylie? Hi, Kylie. Hey, Kylie.
I got
Don't yell at people for not being in class, by the way, because all of a sudden you got really close, and I was like,
Hi, Colin!
I got it.
okay, let's do notes. We
All right.
got this.
So this is
Physics.
your velocity stuff. Average velocity is change in distance over change in time. Instantaneous velocity is just taking the derivative of whatever your position x function is with respect to time. Cool.
Also, how did you do the last?
We're talking about physics.
Physics. We got
Come
notes.
back.
Swap, 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 swap.
I want to know how Katie did the last.
I gotta be on that quiz.
I wrote does not exist.
So let's say we have a position function like this, and this is where your instantaneous velocity might come into play. If you've got a position function like that, and maybe you want to figure out what the velocity is at 2 seconds.
Wait, is this an example?
Yeah. So what's the velocity at 2 seconds if you know that your position is described in this way? Well, not quite yet. That would tell you where you are.
3 plus 4t.
Well, now we got to take the derivative.
Is it 3 plus 4t or 3t 4t?
Well, the 3 is going to go away.
Oh, so
in
it's
relation-
4
I was
minus
just trying to see
10t.
what you wrote there, because, oh yeah, your t's have a third. Never mind.
And then we've got this, the 2 up here, that's going to come out in front, so that'll be 10t.
Yeah.
And then you plug the 2 in. So that's 4 minus 20. Yep. Well, all we really know is we're moving in the negative direction. Though we could take it another step further and try and figure out what the acceleration is. And that's the next step of this whole thing. No, this is velocity. Because we took the derivative of the position function to get a velocity equation, and then we just took the 2 seconds, plugged it in for t, and that got us the velocity at that time. Oh, no.
Oh, okay. That makes sense. Sorry. I was about to use it.
All right, we've got average acceleration we got to talk about briefly.
That was instant velocity.
What's it?
No, I'm just picking this.
Okay.
The one we did before was instant velocity.
Yep.
Like, I'm not saying you stop because, you know, I kind of think it's funny. But,
Well, it's random times that it makes sense to me, but like, I just understood why we wrote.
I understand it too, because it's the opposite of a velocity. It's like an integral function derivative sort of.
Oh, see, I didn't even get that. I just understood why we wrote the letters we did next to D all of a sudden, so you know.
So yeah, this is your average acceleration and instantaneous acceleration. You deal with those the same way you deal with these. If, say, you're given a velocity function or even a position function, you could take the derivative of those, and then if you're looking for acceleration, they're going to give you a time value. You would just plug in that time value, and it'll tell you exactly what your acceleration is at that period of time. You want me to do one of those? Let's say it's
Yeah, do them blue.
Okay. Let's just say it's an easy function here. Maybe position is equal to 4x cubed, and we want to solve for the acceleration when time is at 1 second. So then we got to take the double derivative. The first derivative, the velocity expression, would be 3 times 4, that's 12, x squared. And then in order to get acceleration, we got to take the derivative of that. 2 times 12 is 24, x. And then we would plug our time value in. Actually, this should be a t, I guess.
And that's, it's gotta be T, because you have to plug it in the time.
Yep.
What would be the notation? Would it be some meters?
Yeah. So, for acceleration, yes it was. It would be meters per second squared. Good. Questions on this?
So, that's average acceleration, right? No, it's not.
Average acceleration is this. We didn't do an example of this. If you have two different velocities, you would just take the difference of them and then you divide them by time.
Yeah.
That would get your average acceleration. We don't deal with that quite as much. All right, onward. I also just want to make sure that graphically these derivatives means the right things to you. So remember last year when we did these graphs, position time,
Oh, yeah. It takes me back to a simpler time.
velocity time.
Normal physics.
I genuinely enjoyed them.
Yeah, that was fun.
I enjoyed the points on everything. I got some.
Oh, yeah.
And for being honest, I probably don't remember how to do it now, but last year I did.
This
Sorry.
is where like it went from like straight to then the curve, and then
Yeah.
it stops. So it's straight there, then it's it goes straight diagonal curve, and then it's curved. So it, like there's a little step. Yeah.
Absolutely.
That's what I was gonna say.
Let's say our equation is x squared. What is that going to look like on this?
Like a smile.
Yeah. Half a smiley face. Now, if I take that half a smiley face and maybe I want to figure out what's going to go on with its velocity time graph, can you tell me what the velocity time graph would look like just based on the picture?
Slant.
Yeah, it's going to slant up.
But then the acceleration is wide.
And is that going to be up, down, or middle?
Oh. Oh.
Yep.
I don't remember that.
Because this is a positive slope, so you got a positive acceleration. Now, this is, like I mentioned last year, when you were doing this, you were actually doing graphical calculus without realizing it. Because check it out. If you take the derivative of x squared, derivative of y with respect to x, you get 2x, which would look just like this. And if you take the derivative of 2x, in other words, the double derivative of y with respect to x, that's how you would write double derivative. It's equal to 2. It all matches up beautifully. So you guys are actually doing graphical calculus in regular physics.
I do graphical calculus in my head.
Nice.
Wait, but then you'd have to explain what never mind.
Yeah, now I'm not going to go there. So,
But they would be fun.
in addition to all this, there were some equations that you guys became friends with last year. For your position equations, we had some x's. X equals vt. We generally use this if we have a constant velocity. If you don't have a constant velocity, it does work if you can figure out the average velocity. We also have that big equation. And these are what we'll be dealing with for a lot of this chapter.
Not like me.
Oh, I couldn't help but say that after the comment. And remember, y represents vertical position, x represents horizontal position. And of course, we don't stop there. We've got velocity equations too.
Of course, we don't stop.
Or acceleration equation.
I know, sometimes he just moves and like I'm really close to him, so all of a sudden it's this year, but this year, and it's like
Why did you shut off?
You want to find out?
I was very confused by what.
Okay, well.
We can't see
I'll fix it later. And acceleration, of course, has just kind of two things. Change in velocity over change in time. And acceleration in free fall is equal to negative 9.8 meters per second squared. So these are the main equations you have to remember. You could add one more velocity equation to this. Original plus final divided by 2 is equal to average velocity. I might as well throw it in there. Yeah.
At least the odd one is in the middle.
Yeah.
Thank you.
And these are things that you have to make sure you're aware of. And if you do not still have your formula sheet from last year, you're going to need that. So does anybody in here know that they do not have theirs yet? Because I've got spares.
I probably don't.
I might do hand out some extra ones.
I will bet you I don't.
If you don't have it, you will likely need it for what we're going to do today.
Which day is the Mythbusters Day?
Monday.
Monday.
So who needs a formula sheet?
No.
There's one that's one-sided and one that's two-sided. You need the two-sided one. Are AP one only one-sided?
No, there's only two.
Is this one
Like two.
with kinematics? I'm not gonna be here this next Monday or the Monday following that. So.
I have two.
Okay. All these equations are on your formula sheet or your formula shirt.
I was gonna wear that today, but then no. You should all wear it, and I'll just be the sore thumb because mine's red and y'all's are purple.
And yours is different.
Woo!
Mine is country
You like
road, take
Spider-Man?
me home. And you guys took the one that we were gonna. You guys took our second one where it's like I'm not lazy.
What's
I'm
happening?
full of potential energy.
I am cutting off the power
What?
and hoping that fixes it.
Oh, we fixed a lot of problems.
Sure, I'll turn back on.
Mr.
While you're out there,
Just
can
stay
you
up
put
there.
that
That's
missing
the smart
next
thing for a second.
And then
Stay.
Oh, this is going to look good on the camera.
Everybody look at Mr. Happy. Someone's doing it just like
and on the Wednesday.
He's just trying to fix the projector.
But on that following week,
People in the future, do you guys have fun anymore?
Mr. Hathaway.
Yeah.
Yeah.
I could go with that. Can I do that?
Fair.
You already knew that. Remember when, who was it? Didn't Carlos and Joey
Yeah, sure.
like throw a whole bunch of
You
stuff
gotta
on
hang
the
from your
lights?
chin.
I got a what?
Hang from your chin while you're up there.
Didn't Carlos and Joey like throw like markers up on top or like footballs or something?
I don't remember that. Maybe they did.
Oh, we definitely threw some stuff on top of the lights. I just don't remember what it was.
Crashed a house out on top of the lights.
Why would you do that?
Because we did.
Wow. Hey there, future. Sorry about this.
Now turn on.
Yo, Future is brought you this?
No more class.
I can't believe an icon like Future. is
Please
crazy.
enjoy this music.
Let's go back to that idea of the fight.
So you guys. Oh, AP Fight Club. That's what we should do.
Place your bets. Who would win?
We are going to be doing a
Katie.
problem that is rather long using those equations that were up there.
Oh boy.
And if this was working right, that picture would be up on the board. So just kind of get ready for this. Have a piece of paper out, have your formula sheet out, be ready to solve some problems. I think I can kind of get you started on it, even if it doesn't start up right away.
Wow.
Yeah,
That's perfect.
I am a problem.
You ain't wrong there.
Oh,
Thanks.
okay.
You really don't want to test me, chapter. We would.
All right, I'm just going to draw this. Okay.
These are fun.
No,
Girl, what are you on?
Lack of sleep and I don't know something else maybe. I don't know. Nope, I don't think
the
that.
lack of sleep only makes
Oh.
you more sleepy.
Honor.
I started my day with an AP physics test, which was a
Oh,
great
man.
way to start the day.
What?
Oh, it's because
Oh, was I right? Let's jump in the building.
Doing swim
Your
too.
friends who?
Alex.
Who's Alex?
Never mind.
I do Alex.
Alice.
Alice?
Hey, draw some hair, girl. Who should we make the guy? Did you guys ever? Did you guys?
Yeah.
Please tell me
I
you
got
guys did that last
this
year.
from here. I might be wrong.
Okay, good.
I'm probably wrong.
I think it should be Kylie, so she's included.
During fall.
Yeah, that's Kylie there.
Oh.
That's hers. Mr. Hathaway.
I
Yeah.
didn't know
You know
that.
how you love freshmen so much?
No.
yeah.
I was walking down the hallway today, and I saw two freshmen. They were walking with each other, and then one took their belt and started beating the other one with it.
Whoa. Wait a second. What?
Did you see that?
Oh
Did
no!
you-
Miller
Wait a
Bros.
second.
Well, I'm
What?
thinking my physics Tess, I saw you put on your mask and I thought you were gonna go break up the fight that was happening, and then all of a sudden I heard Mr. Fowler say something.
Yeah, that was fun.
Yeah, it was,
Only at
it
Miller
was,
Grove.
it was a girl and she was hitting a guy with a belt.
Whoa!
Wait a second.
Is that what that was?
Yes, it was like, I think it was after 4th hour, right?
Oh, I didn't even hear that one. There was something going on in the beginning of school.
There's
but-
2?
It was so bad.
Wow.
There's 2?
Only at Martin Luther High
We got it all recorded.
Well, see, this is why we have such a large freshman class. They'll just thin each other out.
Did you see me though? I was taking my test and I had my hands over my ear. I'm like, I can't focus.
That was 4th hour?
The belt thing must have been.
Huh. I don't remember that at all.
No, it was downstairs.
Okay, so here's our setup. And this guy is throwing something up, and it's coming straight down. I want you to solve a lot of things for me, but here's where I'd like you to start. Tell me the time to reach maximum height. This is how I want you to begin.
Tell me your time to make the I'm confused.
No, you're not.
How do you always say you confuse the audience?
So solve for the amount of time it takes for this ball to reach maximum height. The person's throwing it straight up at 20 meters per second. How long does it take to reach the apex of its trajectory?
Okay, so we need to find peak. So,
You're looking for time, so you better use an equation with time in it.
I was about to say, we know that the gravitational pull, so it should
You're using
pretty
the
Girl, why is he jumping off the building? I don't.
He's not jumping off. He's throwing a stone or
That's a
something.
big jump.
Oh, I thought he was jumping.
You want to know the position?
Jumps 20 meters
And
per
who said
second
what
in the air.
happened?
We have a velocity.
I did it. Maybe.
Did you?
Maybe.
Show me how many fingers you got for the answer.
That's an easy one.
I got this many fingers.
How many fingers you got? I got you.
Jaden, who said what?
Well, do your thumbs count or not?
Who said what?
Whoever
And
wrote
your
that
pinky's
movie
not.
directed the movie.
That's called a pinky finger. Yes, it counts. You just don't call it a thumb finger.
Oh,
So does the
well,
thumb count?
thumb is not a finger. That's not like thumb. It's
That's-
Velocity.
The thumb.
Oh, I thought I was going somewhere.
No,
It's okay.
that's your original velocity. It's going up at 20 meters per second. How long will it take to reach its maximum height?
12 seconds.
No.
I didn't start it. That's the original one.
How many times is it in the air? How much?
Wait.
Oh, we're looking for the max.
You know, I never bring my calculator to this class, and every day I
Are
say
you not?
my calculator.
Really?
Is it
You're
7?
gonna do that without a calculator?
No.
Okay.
I was about to say.
I don't even have a calculator with me now.
You know what? I just was thinking that X was Y and Y was X, and so this is.
I feel like this is
like, I was
really
like,
wrong.
I didn't even know how you did that.
Oh, there's the real picture.
Oh, did you draw a fancy thing?
Yes.
Oh, a not so fancy, but a fancy drawing.
I'm not an idiot.
Nice. I like it.
So there you go.
That's quality right there. I see why you were so disappointed it wasn't working.
I know, right? I can't be drawing that well all the time.
I
wonder-
do really
does this show
appreciate though that you just drew like the 3 sides, and I was like, it's a building, and then I was right. And I was a little disappointed that I was right.
Oh, wait. I need to wrong thing.
Oh yeah, I should probably use my calculator.
I'll just turn.
Well, I'm
Detroit City Hall. Can't have stuff in Detroit.
Wait, Amy, you can use an equation that has acceleration. I did.
acceleration's gravity.
Okay. What's my? Do you understand?
Everybody get to see Detroit City Hall?
Yeah.
Okay.
Now, forget it.
Oh, I was like, I know that you know that, but I was like, I forget that is an acceleration value, not a velocity value.
So, finish up as far as you can in the next 30 seconds, and then we'll go through how to do it, and we'll move on.
I have no idea what's happening here.
I respect that.
It's a rough start.
Oh, it's
You
zero.
could, but do you
Zero.
want to? I mean, it's simple.
If you're doing weekly intercepts, yeah.
That's why.
So when you're trying to figure out what equation to use to solve this, number one, you need something that has time in it. Number two, you need something where you know everything else except for time. And the equation that
Definitely.
I go to is this one. Because when you're throwing that ball upwards, the original velocity is 20. What's the final velocity?
0.
Acceleration? Yep. And then you would just solve for time then. That's okay. Did you get the same answer? 2.04? So the answer is 2.04 seconds. There is more than one way to do this.
Somewhere around there. You know.
Okay, I got 1.295.
That's probably just a rounding thing then.
I mean, my way relied on that calculator, so I guess.
Well, give me
Now calculate the max height.
Well, hey, I have that already. That's the way I did it.
And this is the total max height. You can see we're 50 meters off the ground to start.
Oh. Oh. Oh.
You want the time or the
Actual height.
Sorry, I should
Okay, I forget.
push the video.
Game day.
Yeah, game day. That's game day. We're gonna need a calculator for this one.
3 hours, 56 minutes, and 20 seconds.
Thank you, dude.
You're welcome.
I know.
Hopefully everybody's picking the correct equation on this one. There's really only one that you can turn to.
That's what I was thinking.
It's the one I used originally.
Good. We'll hit this one right now then. So we've got that nice long y equation.
It's 70.
That's correct.
Somewhere around there.
So in order to solve for our maximum height, in other words our final height, how high it is when we get up to the top there, we need our original height, which of course is 50. Original velocity is 20. The amount of time it takes to get to that height is 2.04. We just calculated that already. Plus 1/2 times acceleration, which is negative 9.8. And t squared, that's 2.04. And as you guys found out, that's equal to about 70 meters. 70.4 to be exact.
Wait.
I don't have a calculator, so I round it.
That's fine.
Oh, I forgot to add in time.
Did it in my head.
Questions here. So if it takes 2.04 seconds for the ball to get up to this spot, how long is it going to take to get back down to where he threw it from? Yeah. So if it takes 2.04 seconds to go up, it'll take 2.04 seconds to come down to the spot that he threw it from. What is the velocity of the ball when it gets back to where he threw it from?
9.8 times 2.04.
Good guess, but no.
Velocity, when
Negative 9.8.
How fast is the ball going when it reaches this location where he threw it from? Like after he throws it, it goes up, comes back down. How fast is it going right here? What's that? Yeah, negative 20 meters per second, because we're going down now. Oh, did you? Oh, good. Next, I've got a two-parter for you here.
No.
Yay!
Thank you.
I got you.
Oh.
not as good as 3-parters, but 2-parters will do.
That's okay. It's not okay.
Find the position and the velocity of the ball after 5 total seconds have elapsed.
No.
Yes. Yes.
I don't know my
Yeah.
question, but
Yes.
actually gives it back with it saying yes.
That will be. I need a calculator. I felt that one. I got it. I think I got it.
Wait, show me your hand. Do you need to come through here?
Oh, over here.
That's better.
No, it's not like that. I got it. I have my phone.
Wait. Oh.
I just switched my.
He did the one without the calculator.
Yeah.
Another minute or so. Get as far as you can.
I think we have math initial. Since that's the math, which is good. Communicate. No words.
Yeah, me too. From now on, I'm just gonna use this.
Use the football sign language.
What'd you guys get for position?
We've Albuquerque.
Did.
Texas.
27 and a half. And velocity?
Hey, I got that. I didn't get that one, but I got the other one.
Negative 29 I got for velocity.
Smack.
I like the original smack better.
Yeah, we can do that.
From now, it's
Oh,
all
I
this.
thought you got it.
It's all this. It's all this.
This is our last part.
It's all this. Or this.
Yeah, I'll probably have one more. One more after this.
Or this.
So this is what you have for your position. Obviously, you got to use a y equation, which includes time. So there's only one of those. That's what this is. So that comes to 27 and a half. As for velocity, we go back to this one. And you just plug those values in.
You're just trying to find the most creative ways to solve this.
I did the same exact things. I just did it in opposite order. For some reason, I did velocity first.
All right. Questions on any of these?
Yes.
All right. The next thing I'd like you to find is how fast that object is moving when it hits the ground.
The velocity at y equals 0.
Yep,
At the
like
exact
right before.
moment,
Yes. As it makes contact with the ground, how fast is it going?
Is it okay if I use 0.002? Just for fun.
Sure. Couple different ways you can do this one. One of the ways is a two-stepper. One of the ways is a one-stepper.
What's the one step?
That's the one I'll show you at the end here.
One step or two step or three.
Otter got the vocal. We have to use the quadratic formula.
No.
That's right. Because that is slower than 5 seconds.
Because if we did, it would have been my average.
Good old quadratic.
I think we all can agree I sing it at least one time.
I'm very confused with the. Never mind.
I think I did it wrong because I had to use the quadratic formula. Sorry to say, we can't all be a few years.
Are we using?
60 seconds.
Are we using 50 or
I
70?
just did it and I got a
For what?
speed
50 or
at
70
5
for
seconds, so
because you're jumping like that's the max point.
That's the max.
Yeah, I mean,
Going down.
you'd have to use whatever that max height was. Yeah, if you're going to do it that way.
I was solving for time. That's why it was weird.
You guys just love solving for time.
No, we don't.
No, I don't.
Speaking of solving for time, did you know it's like 3 hours, 46 minutes, and 20 seconds until takeoff?
Nice.
Yeah.
Unless they do the anthem at 7. Details.
I'm interested to see the distribution of what methods you guys used for this one. 5 seconds, finish up.
I pretty much always use the same formula. It always works.
Pretty much. So if I'm going to use an equation to try and solve for the velocity at ground impact, I'm going to first look for my velocity equations. And the one that jumps out at me for this one is the one that we always forget. The time-independent velocity equation.
That's the one I'm doing.
Oh, good.
I need to get off.
That's
I
exactly
can't
what
put
I did.
the
I got a
changing
slower
y
velocity
on
than
Original square.
when you than at 5 seconds. So that's why.
Yeah, what's the changing y?
Well, change in y is just negative 50 because you start here, you end
That's
here.
what I was asking you. Is it 70 or?
So why is it slower at ground impact than it is at 5 seconds?
Because it hits the ground in less than 5 seconds.
It should be.
Now I know.
I don't know. I didn't actually get that one.
So you do this, and then remember that gives you your answer squared.
Right.
You gotta
So then you got to square root the whole thing. Yep.
Yeah.
Which is what?
Good afternoon, Flex Kings. An update.
I got negative 37.1.
It's a close race. In fourth place with 121
Yeah.
points. In fourth place with 121 points
let's see.
are the freshmen.
Okay.
In third place with 139 points, the juniors. In second place with 146 points, the sophomores. And the seniors are in first with 164 points. Dress-up days are ways to earn spirit points next week. Class competitions, which is Wednesday the 30th at 6 p.m. coordination
Because our
time.
quarterback lost